In this video, I'm going to discuss the three different forms of quadratics, the standard, factored, and vertex forms. So here are the general equations. Notice that this particular format has no brackets. This one is written as a monomial. There's nothing added or subtracted to create a second term. There are binomials inside brackets, but overall it's a monomial. And this one, x appears only in one spot, unlike in here, there's x's in two spots here as well as here. There are two spots. So let's classify this particular one. First of all, because x appears only once, it could be classified under this category. It can also be classified under this category because it is a monomial. There's nothing added or subtracted after this term. This next example, it doesn't have any brackets, so it could be classified under this category. But also, x only appears only once, so it could be classified here. In this one, x appears only once, and there's two terms here, so it cannot be a monomial, so it can only be in this category, and there's brackets on it, so it cannot be in the first category. And this particular one has no brackets. X appears in two spots, so this one can only be in this first category. And this last one, this is a monomial, and x appears in two spots and there's brackets, so this one only gets classified within this middle category. So what are these categories called? This first one with no brackets is called standard form. We can call it also expanded or general form. I've seen it called. In this form, we can tell what the y-intercept is. So this last number, the one that has no x on it, so the term without an x, is going to be our y-intercept. This middle category is factored form, or we can call it the intercept form, because we can see the x-intercepts, or sometimes we call these the zeros. And in the last category, we have the vertex form, because you can see the vertex from it, but you can also call it the transformed form. So the vertex will come from h and k. And notice how the sign flips for the h. So if in the bracket you see a minus, it's going to be a positive h. If the equation had a plus a number, this would be a negative h. So it's always going to be a swap of the sign for the h. Just like with x-intercepts or zeros, negative r becomes positive r, and negative t here will be positive t. So you have to swap the signs. We also call this the transformed form because if x appears once, we can actually see all the transformations. Another note, because a appears in all of these formats, you technically can tell whether something's being reflected or stretched or compressed in all of the forms. But in terms of shifts left or up, down, or to the right, all those shifts are only visible in this format where x appears only once. So let's start with this particular format, the vertex form. In my opinion, it's the most useful form of all, and the standard form is the least useful in terms of word problems. So let's start with this one. First of all, you should notice that the format up on the top, x, doesn't have any coefficient. And if it had it, it would have been factored outside of the bracket. This example, the 2 is still on the x. So we're going to pull out the 2. So 6 will become a 3 when you divide it by 2. But then this square on the outside can be distributed to each of the factors. So it's going to be 2 squared and then this bracket with a square. So this could be rewritten in this format, which matches more easily to the format provided on the top. And then we can say a is -4, h is -3. So notice in the bracket is positive, becomes negative, and the k is -7. So what does a do? If there's any negative, it tells you that it got reflected in the x-axis. If the number, if you ignore the negative and the number is bigger than 1, you would say it's stretching. And then because this is negative, you would say shifting left, and this is negative, then you say shift down. So overall, from this form, you can definitely tell what the vertex is. And if you were asked what is the axis of symmetry, you would say this first number, -3. And if you were asked for optimal value, you would say this last number, -7. And here would be a rough sketch of this graph. We have our vertex, and we know it's opening down and vertically stretched, so it's pretty narrow. In this example, we have factored form. The easiest thing we can see from it is x-intercepts, but they're more easily visible if x, again, doesn't have any coefficient on it. So it has to be written in this precise form, which this is not quite like that. So what you could do is fix it. You could pull out the 2 from this first factor. So that means 1 becomes 1/2 when you divide by 2. And you can pull out a negative because there's coefficient of -1 on this x. So you can pull out -1 by dividing both terms by -1. And just rewrite it afterwards. So it actually matches the format on the top. So once it matches, then we could say the x-intercepts would be -1/2 and +5. Another way to do this is don't rewrite it in a different format. Work with what's given and just plug in y = 0. So where you see the y, you plug the 0 and keep the original brackets provided. Because it's a monomial, we can say each of the factors could be 0. This is a property of 0. So if we have 2 numbers multiplied together and we get the result of 0, that means one of those numbers were 0. And these linear factors are much easier to solve. So if you move 1 to the other side, then divide by 2, you get x = -1/2, which matches to what we had there. And then if you move x to this side, we'll have x = 5, which also matches here. So if you were to sketch this approximately, we'd have those 2 x-intercepts. And then we know that it opens down because of the a value once you fix the format. So if you do not fix the format, you do not make an assumption that what is in front, +1, tells you how it opens. Because that's only true if x's don't have any coefficients. Then you look at what's in front of the bracket, it's -2, and then you can see that it actually truly does open down. And in terms of how high does this parabola go, we don't quite know this from this format. We know it's opening down, but we don't know that point. That point is easily found from vertex form, which is not the case here. We'll summarize how to find that point in a little bit. And this last format, I think, is the most useless. I mean, it's still useful, but it requires a lot more work to find the vertex and the zeros, which we'll discuss. But as it is, we can rewrite it so that it's in descending powers of x. So x² first, then x, and then the term without any x. And then the y-intercept would be the last constant term. Or you could also say, I need to find y-intercept by substituting x = 0, and then you'd still get the same result of 3. So y-intercept tells you that the graph, the parabola, will cross the y-axis at 3. We know because of the a that it opens down, and it is skinny because of the stretch of 2. But we don't know where that vertex is. So maybe it's here, maybe it's over here, maybe it's on the other side. We have no idea that piece of information until we work with that and find the vertex or find zeros to figure that out. So we'll summarize how to do that on another slide. Let's talk about this equation, which is both factored and vertex form at the same time. Why it's both? Because, well, this is a monomial, so there's nothing added here. And this is also factored form, or sorry, vertex form, because x appears only once. So if you were to really think of it as written in that format, you could just say x + 4 written twice. And so then you would say x-intercept is -4, but instead of writing it twice, you could just write it once because 2 of them are in the same spot. In this situation, you could say there's a +0 at the end because it doesn't change it. And so now it matches that format exactly. And so you could say the vertex is going to be -4, 0. And when you have 2 forms coinciding, then the x-intercept here and the vertex would actually coincide together. So if you were to sketch this, we know we're going to have x-intercept at -4, and this thing will open down from there. Let's do another form that is 2 forms at the same time. So this one is without any brackets, so it could be classified as standard form, but also x appears in one spot, so it could be classified as vertex form as well. So here we can say that there is a 0x in the middle to match that format exactly, and so we could say y-intercept is -18 here. On this side, we could say x squared. Instead of just saying purely just x squared, we could say x minus 0 and then squared, because x minus 0 is still x. So now that format matches this exactly. And here we could say vertex is then 0, negative 18. So if you were to sketch that, you'd say y-intercept is negative 18, but it's also the turning point itself. So the parabola is going to turn at that vertex form or vertex point, and it will open up because of the a value being 6. And so we don't really know these x-intercepts, but that's something we can discuss on the next slide. So here is a summary. These are all the 5 equations that we discussed just now. We're going to talk about what's the easiest thing to find from different formats. Y-intercept is the most easily found from standard form. So this is standard form, so we could say that last number 3 right there. This is technically standard form as well, because you can rewrite it with a 0 in the middle. We talked about that, so you could say y-intercept is negative 18 here as well. X-intercepts, it's most easily found in factored form. So this one right here was factored form. You could fix the form if you want to first, or use property of zeros to find the x-intercepts. This one right here was also factored form if you rewrote x plus 4 twice, or you could just think, well, this is a monomial, so therefore we can see the x-intercept to be negative 4. And these last 3 are most easily visible from vertex form. So from this equation right here, when you fix it up a little bit, you have negative 3 and negative 7 as your vertex. And once you know your vertex, you know your axis of symmetry and optimal value, because the first number is axis of symmetry, the second number is your optimal value. Let's talk about why I wrote down max. How does this parabola open? Because of this negative 4, it opens down. So that means it's a hill. There's a point that's as high as possible. So this negative 7 is a point that's as high as possible. So it's going to be maximum. Do not make a mistake to think if you see a negative on the y value, that has to be a minimum. That's not always the case. So it all matters how does it open. So you have to look at the a value, not the actual optimal value, to write down the word maximum or minimum. This particular one is also considered vertex form because we could always say just plus 0 at the end here. So this is written in vertex form. And so just like before, we can say, well, vertex would be negative 4, 0. So let's switch the sign over here inside the bracket and that number outside here. So negative 4, 0. The first number is going to be axis of symmetry. The second number is going to be your optimal value. And we say maximum here again because of the a value. The a value is negative, so it opens down. And then here, this is still vertex form as well. And if it's rewritten this way, so 0 will be the axis of symmetry number, negative 18 would be the optimal value number here. And why did I say a minimum? Well, the a value here is positive, so it opens up. So if it opens up, there is going to be the lowest value. So this number, negative 18, is the lowest it can get, which we call the minimum. So don't forget, with optimal value, you should always say the number, but also the word max or min beside it. Let's fill in the rest of the chart. How would you find things that are not so easily found? So for y-intercept, you can always sub x equals 0 to find the y-intercept. So it's not as easy as just looking at this number 3 and picking it out, but it's not too hard either. You can just plug it in and work it out to get negative 43 in this case, and then some other numbers. I'm not going to do it right now. Just note that that's the way to find the y-intercept, sub x equals 0. What about finding x-intercepts? Well, it depends on what form you have. Let's start with this one. You're going to substitute y equals 0. So if you do that, you'll have 0 equals in this expression. This expression has x appearing in one spot, so we can isolate for x. So what you do is you do BEDMAS backwards. You're thinking if there's any adding or subtracting outside of the bracket, well, there is this plus 7, so we're going to undo this minus 7 by adding 7. So here it is. Then you're thinking, is there any multiplication division outside of the bracket? Well, there is this negative 4, so you undo this multiplication by division. Here we go. Then we need to take care of the exponent. To take care of the exponent, we need to do square root to get rid of the square. But we cannot do a square root of a negative number. So usually when you do square roots, you put plus minus in front. But here under the root is negative 7/4. That's not going to be a real number. So you would say that this parabola has no x-intercepts, which we saw when we graphed this on the previous slide, that it actually was opening down and shifted down from the x-axis. So if you have vertex form, you could substitute y equals 0 and just isolate for x. Sometimes you'll find values, sometimes you might not. Standard form, substitute y equals 0. But unlike the previous example, we cannot isolate for x because there's two of them. There's x squared here and there's an x here. They're not like terms, so we cannot combine them together and try to isolate for it. So you'll be learning later something called the quadratic formula to be able to find the solutions to this equation. Okay, so for now we'll leave it. And then in this last one, because x will appear once, we can isolate. And so we can say, okay, we want to isolate for x, and we'll do BEDMAS backwards again. So adding and subtracting to undo first. So this negative 18, we're going to add 18 to both sides and get to this. Then we need to get rid of the multiplication by 6, so divide both sides by 6. And then lastly, you need to get rid of the square, which is square rooting. Don't forget the plus and minus, because there's two answers that could cause this solution. So we have a way to find x-intercepts from this format, okay? And last summary, what can we do to find the vertex, axis of symmetry, and optimal value if we have these two middle forms? So let's start with the easier one of the two. So in this particular one, if you have your two x-intercepts, you need to find what's right in the middle of the two intercepts. And how do you find average? Well, you add the two numbers and divide by 2. Once you have that number, you can plug it into the equation to find the optimal value. And then once you have those two numbers, that would be your vertex. If you have standard form, you would have to complete the square and to find the rest of it. I do notice that some people say, okay, we can also find the axis of symmetry by doing negative b divided by 2a, because that's the first step of finding the special number of completing the square. You can be free to use that if you wish, but I would prefer that you show the completing the square steps and finding the vertex in that way.